Somewhere in NASA's $25 billion annual budget, there's a line item for rockets. And it's embarrassingly small. We have all seen the launches. The countdown, the fire, the roar, the crowd going absolutely wild. And naturally, most of us assume that is where NASA spends its money. On rockets. On those massive, breathtaking moments of liftoff that flood our social media feeds. But that assumption is almost completely wrong. And today we are going to break down exactly where NASA's money actually flows. Because the real answer is far more interesting than you probably expect. Let's start with the number that stops most people in their tracks. NASA's annual budget sits at roughly $25 billion. That sounds enormous. And in some contexts, it is. But here is the thing. Relative to the entire United States federal budget, NASA receives less than half of 1%. Less than 0.5% to run the entire American space program. When you frame it that way, the question stops being, why does NASA spend so much? And starts being, how does NASA do so much with so little? The answer lies entirely in how that money is distributed. Here is where it gets genuinely fascinating. The largest chunk of NASA's budget, by a significant margin, goes towards science. Not rockets. Science. This includes planetary science, earth science, astrophysics, heliophysics, and biological and physical sciences. We are talking about missions that study the sun, map distant galaxies, track climate patterns from orbit, and probe the atmospheres of other planets. These programs collectively consume billions of dollars every single year, and the vast majority of that spending never produces a single launch event that trends on social media. Think about something like the James Webb Space Telescope. That project took decades, cost roughly $10 billion, and involved thousands of scientists, engineers, and contractors across multiple countries. The actual launch was one moment, one rocket, one day. But the years of research, the manufacturing of precision instruments, the software development, the testing, the retesting, the problem solving, the international collaboration, that is where essentially all of the money lived. And that pattern repeats itself across nearly every major NASA mission. Now, let us talk about something most people completely overlook. Earth observation. Right now, NASA is operating a fleet of satellites dedicated entirely to studying our own planet. These systems monitor sea levels, measure ice sheet changes, track deforestation, analyze atmospheric chemistry, and model weather patterns at a level of precision that was unimaginable 50 years ago. This work is not glamorous. Nobody is posting countdown clocks for the latest soil moisture satellite. But this data feeds into climate research, disaster response systems, agricultural planning, and infrastructure development worldwide. The economic and humanitarian value of this work is genuinely staggering, and it quietly consumes a meaningful portion of NASA's annual resources. Here is the part that fundamentally changes how you understand the space industry. A massive share of NASA's total spending flows directly into private aerospace companies and engineering contractors. When NASA funds a spacecraft development project, it is not just paying for that spacecraft. It is sustaining an entire ecosystem of engineers, technicians, material scientists, software developers, and manufacturing facilities spread across dozens of states. Companies like Lockheed Martin, Boeing, Northrop Grumman, SpaceX, and hundreds of smaller suppliers all depend on NASA contracts as a core part of their business. This is deliberate. NASA functions partly as an economic engine designed to keep America's aerospace workforce skilled, employed, and capable. Because if that infrastructure disappears during a slow period, rebuilding it would take decades and cost a fortune. And this brings us to the actual launch budget. The part most people imagine is the whole story. The funding allocated specifically to launch services, meaning actually buying rides to space, is a relatively modest fraction of the total. And in recent years, as commercial launch providers have driven down the cost of getting things into orbit, that fraction has become more efficient than ever. NASA can now purchase launches from SpaceX's Falcon 9 or other commercial vehicles at prices that would have seemed impossible 20 years ago. The agency has strategically leaned into this shift, using competition in the commercial sector to stretch its launch dollars further, while redirecting savings into research and development. Let us talk about the human exploration side of things, because this is where public perception and budget reality diverge the most dramatically. Programs like the Artemis Initiative, which aims to return humans to the moon, do receive significant funding. But even here, a closer look reveals that the money is overwhelmingly concentrated in spacecraft development, life support systems, habitat design, spacesuit engineering, and ground infrastructure, rather than in actual launch events. Building a system that can safely take humans to the lunar surface requires years of painstaking work before a single astronaut ever suits up. Every piece of technology has to be engineered, tested, broken, redesigned, tested again, and certified at an almost paranoid level of rigor. That is slow, that is expensive, and that is exactly what NASA is doing with its human spaceflight budget right now. There is also the matter of the people themselves. A significant portion of NASA's operating budget covers the salaries, benefits, facilities, and support systems for the tens of thousands of civil servants and contractors who keep the agency functioning every single day. The engineers at Johnson Space Center who work flight operations, the scientists at Goddard who process satellite data, the technicians at the Jet Propulsion Laboratory who monitor deep space probes billions of miles away. This human infrastructure does not make headlines, but it is absolutely foundational to everything NASA accomplishes. What this all reveals is a fundamental truth about how NASA actually operates as an institution. It is not primarily an organization that launches rockets. It is an organization that builds and sustains a long-term national capability in space science, exploration technology, Earth monitoring, and aerospace industry development. The launches are the visible tip of an enormous iceberg of sustained investment in research, infrastructure, and human expertise. They are the celebration at the end of years of invisible, grinding, brilliant work. This also explains something that often frustrates people who follow the space industry. Why does everything take so long? Why does a mission that gets announced today not launch for 8 or 10 years? Because the bulk of the work, the engineering, the science, the testing, the iteration, all of it happens in those years before the launch. The timeline reflects the genuine complexity of what is being built, not bureaucratic inefficiency, though that certainly exists too. Understanding this also reframes how we should evaluate NASA's performance. The question is not just how many launches happened this year. The question is what scientific knowledge was generated, what technologies were developed, what industry partnerships were sustained, and what long-term capabilities were advanced. By those measures, NASA's output in any given year is extraordinary, even when the launch schedule looks quiet. So the next time a big rocket lifts off and everyone celebrates, enjoy that moment. It is genuinely incredible. But remember that you are watching the final punctuation mark on years of investment, collaboration, and relentless problem solving that never trended, never went viral, and never got a countdown clock. The real story of NASA's budget is the story of thousands of people showing up every single day to build something bigger than any single launch. And honestly, that story is even more impressive than the fire and the smoke and the roar that we all get to see. To stay ahead of what's happening on our planet and beyond, hit subscribe now and watch my newest video right here on an intriguing new discovery.